So we are recording this. Just want you guys to know that this is being recorded, and we will use this lecture later on YouTube. The advantage of this will be that the people who did not see the lecture this morning for various reasons, they would be able to get the lecture this afternoon when I put it onto YouTube. So today we're going to discuss general maintenance on Airbus A310 and on Boeing 737 aircraft. So things like a service check, the different intervals that you do maintenance, general practices that you'll have. So we won't really discuss systems in detail, but we'll discuss how to do various servicing tasks. So I will get these lecture notes up onto the internet a little bit later on, so you'll be able to see what we have been looking at. Now we'll see whether or not this is going to work or not. So at this point, I'm not able to see what you guys see on the screen. So this particular lecture note, it says it's Air France, but honestly, this is just a standard Airbus GenFam course that they have. They refer to this as an ATA 104 Level 1 General Familiarization. So when you get hired at a company, they will probably give you an ATA 104 General Familiarization. And this will teach you just the very basics that you need to know about an aircraft so you can work on it safely. As you progress through your career, eventually you'll take a Level 2 and then a Level 3 course. In the United States, we don't follow this practice. I do think it could be useful to have the Level 1 courses for new employees at an airline, but typically we only go to a Level 3 class. So we would go, you work on the aircraft, sometimes you would receive training, sometimes you don't receive much training, but you learn the airplane by working on it, and then once you've worked on the airplane for, let's say, 6 months, perhaps 2 years, you know a little bit about how to work on the aircraft, then the company invests the money to send you to the Level 3 class. If you take a class, if I take a class tomorrow on the 787, I've never seen the 787. I've ridden on it as a passenger. A350, if I take A350, I've never seen an A350 as a passenger or as a mechanic. So if I were to take the class first and then go work on the aircraft, I wouldn't learn as much. At Continental, they recommended highly that we worked on the airplane first. It wasn't a formal requirement, but it was a recommendation that at least give ourselves 6 months to work on an airplane, become familiar with it. So we have a system of using zones for the aircraft and the XYZ axis, which perhaps you've discussed elsewhere. So our x-axis on an aircraft, if we're going to try to look for a component, you would be looking for something on the fore and aft axis. Y-axis would be left and right. So if you remember, right down the center of the aircraft, they call that the zero butt line. So if we were 5 lbl, that would be 5 inches left of the center. Some of your Airbus references that they have, they do tend to use metric. So they'll use centimeters, millimeters. The 737, all of your stations are all identified in inches. You'll notice that the XYZ, they've drawn this in front of the aircraft. And they haven't drawn it here to help you to see X, Y, and Z. They've positioned it out here in front of the nose because your 0 point on your x-axis is located forward of the radome. The reason that Airbus has done this, many aircraft manufacturers will have your 0 datum on your x-axis. They have it forward of the radome because perhaps they're going to do some kind of a special modification where they put a different nose on. You might have a different probe that sticks out the front. They're trying to avoid having negative numbers on your x, just to make things more simple. It also reduces weight and balance errors. Some of your general aviation aircraft, they will have the x-axis 0. They'll have that at the firewall. So then anything anything that is forward of the firewall becomes a negative X. Everything aft is a positive X. So some mechanics, they've made errors in their weight and balance calculations by not having a negative number. So for Airbus and Boeing, both of them, 0 is forward of the nose. So if we have, let's say, a lightning strike, we see a burn mark on the aircraft, we wouldn't take a tape measure from the tip of the radome and measure back here and say 0 is here. You'd have to realize that 0 is some imaginary point in space out in the front, and you would have to figure out that perhaps the frame right behind the cockpit here is at a certain X dimension. Then you measure back from there and you calculate how many inches or centimeters you are further back. As I recall, Airbus, their station charts I've seen in some of the manuals are in centimeters. I don't know if they do this on all of their aircraft, but I have seen some models of them that I've seen documentation in centimeters. 737, though, it'll be entirely in inches. So station number 727 on a 737 would be in the center wing box area. You can measure forward and aft from there and make a description of your damage. Z-axis is above and below the water line. So basically this right here would most likely would be the floor beam on the A320. On the 737, the floor beam is your 0 datum point. So X is aft distance from station 0. Y is our lateral distance from AD. They say AD, and that means your butt line, your center line of the aircraft. And your Z is your vertical distance from FD. And fuselage datum is your 0 point right here. They're showing your water line. Fuselage FDZ 1060 is your WD, your wing datum. So all of these different things, if you're trying to describe where some damage is or you're trying to locate something to fix it, like perhaps you had a dent that's on a repetitive inspection that you have to inspect, say, every 500 hours, then you would use your X, Y, and Z coordinates to locate that component. ATA chapters, your structure of Airbus manuals is in accordance with ATA specification 100. ATA 100 specifications will divide up your manual into chapters. ATA chapters, a lot of you are familiar with ATA chapters from NDT. So for example, the fuselage is ATA 53. The wings are ATA 57. Vertical stabilizer and horizontal stabilizer and the rudder and the elevator are ATA 55. Notice that the rudder and the elevator are not ATA 27. ATA 27 will cover the controls that will move these flight surfaces, but the actual control surface, the rudder and the elevator, these are all in ATA 55. ATA 55, that is stabilizers. APU tail cone, ATA 53, because the structure around the APU is part of the fuselage ATA chapter, so that's ATA 53. Our wings are ATA 57, which brings us to a point that some new technicians may not be quite as aware of. If you're looking for troubleshooting on the aileron, the control of the aileron, the hydraulic controls, electromechanical controls, cables on a 737, these would fall under ATA 27, flight controls. But on both aircraft types, your flaps, if you have some things with the flaps that you need to look up, you need to consider ATA 57, because the flaps are not considered to be flight controls. They're considered to be more part of wing structure by some of the engineering people that write the manuals. So if you have an aileron problem, you look in 27. If you have a flap problem, you will most likely end up looking in Chapter 57. Some aircraft you'll look under ATA 27 for your flats, but if you don't find any information there, it is going to be in 57. Then they have sections for your zones. So for example, they're saying here our slats are in section 24, our flats are in section 27. So they subdivide the ATA into subsections. Your nacelle, they say is section 42, pylon is section 41. And that would be the same if you have a CFM56 engine or a V2500 engine. Airbus has two possible engine types that you can choose from for your aircraft. 737 only has CFM56. CFM56-7 for 737 new gen aircraft, and you have CFM56-5 engines for your Airbus. I do not understand why this does not show what I'm broadcasting, so I hope I'm sharing with you everything that you want to see so that this will actually be worthwhile. Big limitation for me as a teacher is as I'm talking to you, I cannot see what you get to see. So you had station numbers and you have frame numbers. So your zero datum is out here. Station negative, you see there's a negative here, there's a minus here. Minus 350 is frame number 1. I'm sorry, that actually isn't a minus. So station 350, there should not really be a minus here because 0 is out here. So station 350 is frame 1. Station 950 is frame 24. So some of your documentation will mention your frames in terms of locating where damage is or areas that you need to inspect. You have structural breakdown in zones and ribs. Horizontal stabilizer, they'll locate items as well in reference to the ribs. And each of your ribs also has a station number. So your station is 0 here, and then you can measure outward from there and determine where your inspection item is on a horizontal or vertical stabilizer. And you break the aircraft down into zones. We have seen our major zones before. So if you had an inspection card that was in zone 400, that would be on your right engine. And there's probably enough about zones. This is a most important thing to remember on all Boeing and Airbus airplanes. Three jacking points. If we're talking about jacking the airplane up, raising the airplane, if it's a Boeing 777, Boeing 737, Airbus A300, Airbus A320, you're going to have many places on the aircraft where you can put a jack under the airplane to support it. If you're in the hangar and doing major structural work, you're going to start cutting into the structure on the wing. You may have to support the wing just because of the type of maintenance you're doing. Or perhaps your airplane is outside and you're going to change all of the landing gear, but you don't have a hangar available. You're going to change all of the landing gear on a 747 and the plane is outside. But it's very windy in the evening in LAX. The plane is outside and it stayed outside for 1 month. We did this. We changed all of the landing gear on a 747. You only jack the airplane at 3 points. The magic number is 3. I mention this because on an A300, back in the tail near the APU, there's a place where you can put a jack. And I had a supervisor that when he was at Pan Am, he got 4 jacks to physically raise the A300. So he put a jack up in the nose, he put one on each wing, and he put one on the tail, and then applied pressure to raise the aircraft using all 4 jacks. And he put the jack and the tail through the airplane and had a big hole because structurally the airplane is not strong enough to lift the aircraft with all of the points on the aircraft where you can put a jack. If you have it outside, you might have 12 jacks on the aircraft just to support it because it's windy, to keep it from tipping, falling off of the jacks. But you only physically can raise the aircraft with 3 points. So remember that on A320, I guarantee there will be some kind of an exam question. And if we're talking about jacking, lifting the aircraft, the magic number will always be 3. This I can promise will always be the same. And I'll see if it mentions anywhere about other points that you can put jacks. They may not mention it in this particular point here. So on the wing, you have a wing jacking pad. A320, you're actually going to have a tool that you're going to have to bring to the aircraft and attach to the airplane. So you have to install the jacking pad. That does not come on the aircraft, does not come installed in the airplane. Bit of a limitation because you're probably not going to find jacking pads stored on your aircraft. So if the plane is in a remote airport in another country and you get to where you need to go out and actually jack the whole airplane up again for some maintenance purpose, you would have to fly your crew with the jack pads to be able to do this type of work. At the nose, there's a jacking pad there also. This does not stay attached to the airplane. This is something that you slip into the aircraft, and this would be part of a toolkit that would normally not be supplied with each airplane. So this is a bit of a limitation on the A320. If you have to do aircraft jacking, you're going to need special tools beyond just having jacks. Your jacking point is identified by a external placard. It shows here that there's a jacking point. So you would have to remove this and then install your jack pad. So you have a jacking point there. They call the one at the tail a safety stay. So back here, you can put a jack back here to keep the airplane from tipping in the wind. However, if you put 4 jacks on the airplane and you simultaneously apply pressure, I promise you, guarantee 100% of the time you will put a hole in the airplane if you try to lift the weight of the aircraft using what they are calling the safety stay. There are other words in the English language that would have been better to use than stay for this positioning point for jack. And now my Acrobat Pro is not responding, so we have to wait until Windows 7 straightens itself out so that we can continue to work. Once it's ready, then we can continue. There we go. If you're going to do anything with the aircraft, often it requires you to know if the airplane is level. So if you're jacking the airplane for maintenance, you want to make sure that you maintain it as level as possible. So this will show how much left, right, up, down bank you have on this attitude monitor. And you'll notice that it says A through G and then 1 through 7. Instead of just having an X and a Y axis and having a 0 in the middle, they have this particular setup where they have this 1, 2, 3, 4, 5, 6, 7 from left and right. But you want to get it so that this air bubble here is centered. That way you know the airplane is perfectly level in your attitude monitor. And that is permanently installed at fuel access panel door 192 MB. You also have within your ADARU, within your aircraft computer systems, you can also go in and see if the aircraft is level here. So there's a leveling and a weighing quick procedure with the Aderoo. They have an enhanced and they have a classic. So with A320s, you'd have to know, do you have classic software or do you have enhanced software? This is an important thing. If you're going to tow the aircraft, do not tow the aircraft if the dimension H is more than 300 millimeters. If you do, you can cause damage to the internal centering cams of the nose landing gear. You also do not want to tow at a speed of greater than 15 miles per hour. I don't know if they mentioned it in here, it's mentioned in the manual, but there is a maximum speed, and they did not mention the speed. Perhaps some of you might see the video. The accident just happened about 18 hours ago. There was a tow tractor pulling a A320 in LAX, and the tractor stopped, the airplane did not stop. Honestly, it doesn't look like he was going very fast, but I think he was going more than 15 miles per hour. So the tractor stopped, the airplane did not stop, and the airplane hit the tug. Luckily, he had a metal cabin above him, and the person towing the airplane was not killed. Might have been lucky, he may not have gotten hurt, but at the time the video got released, the accident had just happened, and nobody had gotten out yet to see if the person could be extracted without cutting the tug open. So when you're working around the aircraft, you're going to have to be aware of the fact that you're going to have dangerous areas when the engines are running. So this green is showing your entry corridor. So if you had to go work on the engine, make sure that you stay behind this particular line. This is very close to where the fan cowl opens up on the engine. If you tried to walk to the front of the engine and walk in between the engine and the fan cowl, you would get sucked into the engine. That is not an approved way to get towards the engine. If you have to get in underneath the fan cowl, you would want to go underneath or approach from the rear of the fan cowl and then go towards the front of the engine. One place I worked at, we did have a mechanic get sucked into a 737 engine. He was lucky that technicians nearby grabbed his legs and kept him from going through the engine, but he lost his headsets, ID badge, everything in his pockets. Everything went through the engine. And it's because he tried to approach the engine from the front while the engine was running at minimum idle, not even at high power. So at high power settings, then you would not want to approach the engine at all. You'd see your danger zone extends all the way around and underneath the engine. And this is out to a radius of 6 to 7 meters is what they say. 19 feet to 21.7 feet or 6.6 meters. Why they can't just have round numbers, I don't know. But this is life. You'll notice that your danger area behind the engine at takeoff thrust is considerably more than it is at idle. At idle, we have an area here of 105 kilometer per hour exhaust gas. You'll notice, interestingly, at takeoff power that this velocity is not any greater. It's still 65 miles per hour, 105 kilometers per hour. But the width of the cone is much greater at takeoff power. Parking and mooring is always mooring the aircraft. You would actually chain the airplane down. You'd physically restrain the aircraft in case you have an airport with high winds and the airplane's going to sit unattended. These type of chocks, when you see this, it's somewhere in Europe. that they use these type of metal chocks. If you're going to install something like this lock that's here, they have an actual physical lock that's on the actuator to keep the airplane from retracting. You want to make sure that you have a streamer that is at least 36 inches long and 3 inches wide, red streamer that says remove before flight. This one here, I can see that they do have a cable coming down, so I imagine that they had a actual ribbon on it that was meets the specification. And if you're going to install any kind of locks, pins in the landing gear, you want to make sure that they have streamers that say remove before flight. Mooring the aircraft is different than parking the aircraft. This is the difference here. And you'll very rarely ever find anybody mooring aircraft because a lot of airports don't have an appropriate place where you can attach ropes or chains to actually physically chain the airplane down. But if you're going to moor the aircraft, mooring, this would be covered under ATA 10, as I recall. So if you're going to be working on the aircraft, you want to follow some kind of a routine so that you know that you've seen everything on the airplane. Your maintenance procedure will probably show you something, a job card, that'll have you flow around the aircraft so that you see everything. This diagram right here, actually, the problem that I would have with this is it never has you look at the tail or the APU. So you're going to want to start up at the nose. As you come down along this side of the aircraft here, you look at the forward cargo door. You'll check your nose landing gear, tires, the extension of your nose landing gear strut. Come down to your wing. You'll look at your leading edge of your wing. You look along the sides of the fuselage. You'll check your engine cowling, make sure all the panels are secure. Look for leaks. You'll look at your landing gear. Look at the tires, the brakes, the extension of the strut. You look for leakage, look along the leading edge of the wing, look for damage, leaks. Then you would come back along here, look at the aft cargo door. You would look at the APU, the horizontal and vertical stabilizers. But the intention of this drawing here is they're showing that you would flow along the airplane just about the same way as a pilot would as well. Start at the nose, work your whole way around, make sure you don't skip anything. You don't want to have you don't want to get into a practice of maybe look at the nose wheel, then look at the main gear wheel, look at this other wheel, kind of look at your engines a bit, and then think that you're finished. You want to actually go all the way around the airplane in a nice, even flow. If you get distracted, say you're here and somebody asks you a question and distracts you, you want to go back 2 steps. We don't mean physical steps. Go back 2 steps in your job card to before the time you were distracted. So if you're point number 2 and somebody asks you a question and you get distracted, you wander away from the airplane, then go back and start over again. Go back through the whole flow. Make sure that you don't miss something important. So on this, they're going step by step. And in this procedure, they're asking, are we electrically grounded? Have we grounded the airplane? Now, if you're in a hangar, absolutely, you're going to have the airplane grounded in a maintenance hangar. A lot of your flight line environments, though, in the US, a lot of your airports, you have a point here where you can ground the aircraft. You might have the cable, but at Newark Airport, for example, there were no earthing grounds at each gate. This is a rather strange thing there, that there was nowhere to actually physically ground the aircraft to the earth. We were fueling the aircraft, we would ground the aircraft to the fuel truck, but then there was no procedure to actually ground the airplane to the ground. This became a bit of an issue during one contract negotiation because people were saying, well, there's maintenance procedures that say we should ground the airplane to the ground, and we can't ground the airplane, so we're not going to work. But this is not very sensible. So the first and most important thing you should do, though, is you should make sure that your nose landing gear steering is disengaged. So you want to move from the engaged position to the disengaged position and install a steering bypass pin. The streamer that they're showing on this illustration would not be 3 inches wide and 36 inches long, and therefore would not be something that's long enough that you can guarantee that it will not be overlooked by a pilot or somebody working on the ramp prior to trying to dispatch the airplane. Quite often these streamers, when it's windy, they'll get wrapped up in the landing gear. So you want to try to make sure that when you put one of these in, the streamer is hanging down and that it will be seen by the pilot and by anybody else working on or around the aircraft. They're showing a landing gear safety pin. So if you have a landing gear that uses a safety pin, you would want to install that. You want to ensure that you have your chocks in place. Your company's policy will be different. Everybody's company's policy is different. Some airlines will require chocks on the nose wheel and one main landing gear wheel, each wheel to be chocked. Some companies will say the chocks have to be firmly against the wheels. Other companies will say that once the parking brake is released, you want to have a bit of space between the aircraft and the chocks. So they want the chocks close to but not touching the wheels. You do whatever your company says. If the aircraft gets fueled or it settles, pinches on top of one of these rubber chocks, you can get a tug, pull the airplane forward, get the chock out. This is not a big deal, but you have to do whatever your company says. If they want the chocks firmly against the wheels, you do so. At Continental, we put the chocks against the wheels. Another company that I've recently looked at their training material, they say that they want a space between the chocks and the wheels so that the tire doesn't get pinched up against the chock. And the reason is because they're doing a lot of through flight work in countries where they don't have their own equipment. So they don't want to have to call somebody with a service company with a tug to have to pull the airplane forward to get the chock out of place. When you fuel the aircraft, very likely the airplane will roll a little bit. Interestingly, once you put the chocks in as well, your procedure for the most part will be once the chocks are in place, you will release your parking brake. Most airlines, you only use the parking brake momentarily, and then once chocks are in position, then you release the parking brake. Again, this is something that it depends on your company's procedure. And keep in mind, if you set the parking brake on any of these aircraft, usually you'll have an annunciation light saying the parking brake is set. If you leave the airplane sit for about 3 days, that light will make your battery discharge enough that you will not be able to get your APU started. Here then they are showing that you will check your external power cord, make sure that it's nicely installed, and your nose landing gear doors are closed. On an Airbus aircraft, if the nose landing gear doors are open and somebody stands up inside the nose landing gear area, if somebody turns on hydraulic power with the pumps in the airplane or applies hydraulic power with an external cart, those doors will close instantaneously and they will kill whoever's inside the door. Airbus A300 aircraft, very similar system to the A320. They killed people at least 2 times that I know of at Eastern Airlines. You want to stay out of any kind of hydraulically operated nose landing gear door area unless you have safety locks in place to prevent the landing gear doors from closing. So here they're showing in the gear, chocks in place. Airbus is showing a chock that goes across both landing gear tires. You have a ram air turbine control panel. Ram air turbine. They're showing a safety pin going through the ram air turbine. You would put this in only if your maintenance manual told you to. You'd have to have a job card as well, something telling you to put that pin in. because you want to make sure it gets removed again before flight. If somehow you put a rig pin in, the aircraft that got dispatched with the pin still in, then you cannot use the rat in case of an emergency. Ram Air Turbine will provide backup electrical power in the event that you lose both of your engine generators. In Pakistan, the gentleman recently who landed with the landing gear up, he managed to lose the engine oil from both engines. Therefore, both engines failed, and the airplane was flying with rat power. This is providing electrical power to fly the aircraft. And unfortunately, they did not make it back to a runway. If you install things like the safety downlock sleeve that they show here, this Airbus diagram, they have forgotten to put a streamer. You want to make sure that you have a streamer 3 inches long, 3 inches wide, 36 inches long, that says remove before flight. So make sure that you have the correct streamer. I keep mentioning 3 inches wide, 36 inches long, because some of the aircraft I've worked on, they were given streamers on equipment, and they were not long enough. There was a 757 that crashed in Peru because it had covers on the pitot probes, so therefore they didn't have airspeed indication. And the streamers that were supplied with the aircraft originally, they were not long enough, and the aircraft, I think, dispatched at nighttime, and for whatever reason, the pilots did not notice that the covers were still on the pitot probes. You will have access doors to access your engine to service engine oil and whatnot. So your oil access door is on the left-hand side for a CFM56 engine on the A320. On the 737, the oil access door on the CFM56-7 engine is on the right-hand side of the engine. The gearbox is on the right-hand side on the 737. Your oil access door on an A320 for the CFM56-5 engine, they put the oil access door on the left. On the IAE V2500, on the left side, you have the oil access door to service your oil. On both, on the CFM56 engine, you have 4 thrust reverser panels that'll deploy and give you reverse thrust. On 737, you're just going to have 1 sleeve that comes back and it has blocker doors inside. We'll discuss that a little later. One of the most important things, if you learn nothing else today, is these latches on the A320. People have amazingly managed to close engine cowlings on the A320 and not get it properly closed, properly latched. And there have been 20 aircraft lose the fan cowlings in flight because of not getting these correctly installed. You can adjust this rod end. This is threaded, and you can thread it in, thread it out. That'll change how much pressure it takes to latch your latch for your cowling. You want to make sure that this is always within the limits that are prescribed in the manual. There's a certain number of pounds of force that have to be applied to latch or unlatch these latches. If they're really easy to close, you might want to get the manual and readjust it. And you may have to get an inspector. You might have to get quality control to verify the rigging. Depends on your company's procedures and policies. There have been cases where these hooks, as they go up to try to engage into the cowling, that there's a little pin that sticks out the side, that it has become impinged. It is pinched. So the handle may look like it's up and stowed, but the actual hook did not go around the dowel that's through here. So that the panel looked like it was latched, but it wasn't properly latched. Anyhow, they've lost 20 of these things in flight. This has become a very big issue on A320s. So preventing fan cowl loss is a very important factor in any maintenance program on the A320. And somewhere here I have something about preventing fan cowl loss. Perhaps after break time. Let's see here. They're saying here they want you to check all your circuit breakers, make sure all the circuit breakers are closed. If you have a circuit breaker that's open, the airplane arrives, and you have a circuit breaker that is popped, most likely your pilots will have said something, because almost any circuit breaker that you open on an A320 will generate some kind of a maintenance message. You will have something that will tell you that some system is not powered. If you find one that is out, it's open for some reason, before you push it back in, you will have to investigate and find out why this circuit breaker is popped. The function of a circuit breaker is to open and protect your aircraft wiring. You want the circuit breaker to open before the wires begin to emit smoke. The correct FAA answer on a test is before wires emit smoke. This means before your wires catch fire. I have an electric fan here right now. You cannot see it, but I have a wire that it started to spark this morning. You can see actual visual sparks, and it was probably going to catch fire as well. So before you put a circuit breaker back in, you'll have to figure out, why did it come out? Your wires were getting hot. Your circuit breaker has opened to protect the wires. If you put the breaker back in again, you might cause an electrical failure. You might cause a fire in the aircraft. Your wiring harness can catch fire. This happened at one airline I worked at previously. The mechanic pushed the circuit breaker back in and held his finger on it, and the circuit breaker melted internally, so it didn't open again later on. There's a short circuit in the wing wiring bundle. The wiring bundle eventually caught fire, and then they had to rewire the aircraft. This took them probably a good 10, 12 days to do this work, and then they had to do a lot of reporting because they had an in-flight wiring fire that was caused because somebody had pushed and held in a circuit breaker as some kind of a joke, and it didn't pop again. Now, the technician didn't stop to think that maybe he had actually caused the circuit breaker to fail, so that it wasn't going to open again to protect the wiring. You would look at your emergency equipment that you have in the cockpit during a service check. You will check things like fire extinguishers, and that is not an aircraft fire extinguisher. Look at the condition of your smoke hood, fire protective gloves, your crash axe. Make sure your life vests are behind each seat. Make sure the bags are sealed and in good condition, and the life vests are not expired. They have an expiration date on them. They have to be sent in and re-inspected. Look at the condition of your oxygen mask. Your oxygen masks will have a microphone inside the mask. If you momentarily push the buttons on the side of this, you'll get a flow of oxygen through the mask. You can also test the microphone at the same time to make sure that the microphone is working. If you can hear the microphone is working, then you know that that is good. You'd also want to check the condition of any wiring for the microphone, because any short circuit from the wiring will cause sparks in this hose, which contains pure oxygen, and then you can have a fire. This has happened on several occasions. Most significantly, there was a 777 that was destroyed by an oxygen fire that started in the oxygen mask in the cockpit. Luckily, Egyptian Airlines, they were at the gate, so they were able to evacuate the aircraft. Then you would look at your center pedestal for condition. Make sure your thrust levers are set to idle. Your engine master switches are set to off. and your ignition mode selector is set to normal. Your flap lever, you want to make sure your flaps, that this lever is set at the same position that the flaps are at. If for some reason the pilots left the flaps extended when they taxied in, if you put this back up to 0, the flaps are still extended. Once you apply hydraulic power, the flaps are going to move to match whatever the position is of your handle. This could result in somebody troubleshooting out on the wing, looking at why the flaps are still extended, and if you turn on hydraulics, then you might kill that technician because the flaps will begin to move. Your gravity gear extension should be in the reset stowed position. Your speed brake handle should be set to retract disarm. Your radar should be set to off. Before you start working on the aircraft, you should make sure that the radar is not going to turn on. If you apply power, for example, and the aircraft had come in, the radar was still set on, you'll begin to emit radar emissions, and this could cause injuries to personnel. It can cause burns if somebody's close enough to the radar. You can also cause a fire. For example, if you're fueling and you operate the radar, you can cause an explosion. Then you check your overhead circuit breaker panel, make sure all the breakers are in. And then you can apply your power as required to do your checks. And you'll follow your maintenance task instructions on your job cards or on your maintenance manual. You want to make sure your window wipers are turned to off before you turn power on. If for some reason somebody has moved one of these selectors, you do not want to operate windshield wipers if the window is dry. Your battery voltage has to be above 25 volts. If for some reason your battery voltage is not showing 25 volts, then you want to either replace your battery or get an external power source and charge the battery so you have more than 25 volts. You will not get the APU to start if the voltage is much lower than 25 volts. And you will follow your safety controls checklist. Whatever the current revision is in your manual, you might have a checklist in the cockpit that you'll follow. You might have something in your printed job card. You might have something in your iPad that you may be carrying around with maintenance manuals. You will follow whatever your company's procedures are. This particular instructional manual is from 2006, so there may be changes to any of this information that may have occurred since then. You want to make sure always that your landing control lever is in the down position. On an A320, if you move the landing gear lever to the up position, and then you turn on hydraulic power, your nose landing gear will retract. If you're at a jetway, then that means your passenger entry door is going to contact the jetway and probably get ripped off the aircraft. You will have extensive structural damage to the underside of the fuselage. You might also have damage to your vertical stabilizer and rudder if there's a hangar and your aircraft hits the hangar. We had an Airbus A300 in Continental Airlines that somebody put the handle in the up position to do some wiring checks. Another set of technicians, they turned on the hydraulics, the landing gear retracted, and the vertical stabilizer hit the hangar, and the nose got damaged on the floor of the hangar when the plane hit, so it got damaged in several locations. Any commercial aircraft, if you turn on hydraulics with the landing gear handle in the up position, if you do not have a lock pin or a lock brace, lock collar, promise you your landing gear will retract and you will have the airplane sitting on its nose. Is it break time yet? Is anybody listening? Can anybody hear me?
I don't
Is it
think
break
it's break
time
time
yet?
yet.
Audio check. Is it break time yet? Lovely.
I don't know.
You don't know if it's break time yet, but you can hear me. This is good.
Yeah.
It's very strange because I do not hear me, which is unusual. I checked this before lunch, and it worked fine, but now it doesn't work. But this computer is from 2551. It's pretty old. You know what? Why don't I do this? So ATA Chapter 12 describes servicing. So our servicing on A318, 319, 320, 321. And it's broken down into replenishing, scheduled servicing, and unscheduled servicing. This can cause a bit of confusion when you're looking through the Airbus manuals. You may want to do some servicing on a hydraulic system. Keep in mind that you may have to look at ATA 12-10, 12-20, and 12-30. So there may be things in different parts of ATA 12 that all pertain to your hydraulic system, for example. This is one system that they do have things in each of the three sub-chapters. So it's good to be familiar with your maintenance manual system. So as you do your servicing, then you'll be able to find the information that you need quickly and be able to make sure that you found all of the information that you needed to find. So if we have a landing gear we want to service, we have to put fluid into the landing gear. We also have to put nitrogen into the landing gear. So some of the manufacturers, Airbus for example, the fluid will get added in one part of the maintenance manual. The nitrogen gas is considered to be gas servicing, not fluid servicing, so they put the gas servicing in another part of the manual. ATA Chapter 12 will probably be the manual system that you will use the most often. Most of what you will be doing will be routine maintenance in ATA 12. So for general practices, you'll want to make sure that the flight control safety locks and warning notices are in position. If you're going to work on the wing, you want to make sure you're always attached when you're out on a wing. They have safety cables that you can attach to the wing and then attach to your harness. In ATA 12-10, replenishing, general description and operation of ATA 12-10. Your fuel system will be in 12-11. Hydraulic fluid is in 12-12. Oil is 12-13, so on and so forth. So in your replenishing, if you have a landing gear shock strut that comes in and it's a little bit on the flat side, you may have to add fluid to the hydraulic system part of the landing gear. That would be in 12-12. Then the gas would be in 12-14. So hydraulic power servicing on the reservoirs, 12-12-29. Fill the hydraulic fluid reservoir with a hand pump. You do not want to get this fluid on your eyes or skin. You want to make sure that the flight controls are clear before you pressurize or depressurize a hydraulic system. You might get some movement. Your elevators, for example, might droop. You might hit a vehicle or a maintenance stand that might be there. So you want to make sure that your hydraulic surfaces are clear before you pressurize or depressurize a hydraulic system. You want to use the correct consumable materials that are listed in the manual system. So in this case, they say that you can use these different materials. These are all different hydraulic fluids that you can use. You would not service your hydraulic system with hand soap. There was a mechanic at Eastern Airlines one time that didn't have any hydraulic fluid, but they had some liquid hand soap. And they put this into the aircraft, and then the hydraulic fluid started foaming. Pilots immediately knew something was wrong with the airplane because he had surges in the pressure. And then this mechanic confessed that he had serviced the airplane with hand soap. So then that meant they had to flush the hydraulic systems. This is not a fun job to do in an Airbus. It takes about 12 hours to do this. And you need about 150 gallons of hydraulic fluid. And once you flush the hydraulic systems with this fluid, you have created hazardous material you have to get rid of, so it's a very expensive process. So here they're showing where we would service the hydraulic system on the A320. So underneath the left-hand wing root at the trailing edge in this fairing, you will find that you have an area where you can fill this hydraulic system with a hand pump. You have a quantity indicator, reservoir fill system selector valve. So you'd reposition this selector valve to which system do you want to fill? Green, blue, or yellow system. So you would move the selector valve, your needle would indicate what your quantity is, and then you would use a hand pump. Use this hand pump here to fill the system until you reach the desired amount. And then you can hook up in here to a either a reservoir fills like a self-contained container, or you can do what usually I ended up doing, which is you had a hose, you put the hose into a can of hydraulic fluid, a 1 gallon can, and you use the hand pump to fill your hydraulic system. Landing gear servicing. You'll notice here that they say task 12-12-32. Lowe's landing gear shock absorber, oil replenishment, and nitrogen filling. In this task, they've given us both at the same time. We can service with our oil and nitrogen with the aircraft on wheels. A320, they have a procedure where we can service the landing gear shock struts with the aircraft on jacks. So without the aircraft having any weight on the wheels, we can properly service the oil and the nitrogen. So this particular procedure is for aircraft on wheels. You want to watch warnings. If it says warning, that means if you do not follow all of these steps, this could result in death or injury. If it says caution, then it's something that's more likely to cause damage to the aircraft, maybe not injury or death to the technician. So warning, caution, and then they have note. Note might be something that if you don't do it correctly, you may end up with operational problems with the aircraft, but they didn't consider it to be significant enough that would cause death or injury or damage to the aircraft. But a lot of times things that are considered as note still will cause problems. So warning, put the safety devices and the warning notices in position before you start a task. You want to stay clear of your flight controls, landing gear doors, components that move, until you put a notice in the cockpit telling people do not move your flight controls, do not apply hydraulics, don't raise the landing gear. Perhaps the airplane's on jacks. You would probably want to have somebody in the cockpit not raise the landing gear handle if you're working on the airplane on jacks and you're in the landing gear well. I did work somewhere where there was an inspector on the ladder and somebody raised the landing gear with him on the ladder inside the landing gear area. So he got pinned in the gear well with the ladder because of lack of communication. The person in the cockpit raised the handle and wasn't aware of the fact the inspector was there, and the inspector wasn't aware of the fact that somebody in the cockpit was going to raise the landing gear handle. Luckily, only the ladder suffered injury during that one. You want to make sure ground safety locks are in position on the landing gear. You have safety locks you can put on the landing gear to prevent it from moving. The aircraft's weight is on the wheels. We're servicing on the wheels. If you're working on the nose gear and somebody raises the nose gear handle, and you're working on the nose gear, the nose of the aircraft can fall on you. So don't just take it for granted that the airplane's on the ground and you don't need to put the locks in position. Notice that they say, if possible, it is recommended that the nose landing gear shock absorber is replenished with the aircraft on jacks. So for A320, their recommended procedure is that you do the servicing of the nose shock strut with the airplane on jacks. However, it's not required. You can service it with the airplane with the weight on wheels. However, they do say it must be a minimum of 2 hours since the last aircraft operation. This is time, it gives it time for the nitrogen and the oil to separate from each other. You may have some nitrogen trapped in your oil. This would give you an erroneous servicing if you did it on a through flight with only 45 minutes of ground time. Then you would probably wish to ask somebody on midnight shift to let the airplane sit for 2 hours and then recheck your shock strut servicing. You always want to use calibrated equipment. This would be in your tool crib. It would be controlled under a tool control program. So let's see if we can show you a diagram. So on the nose gear shock strut, we have the servicing point at the top of the gear. You have your filling assembly. Then you would install an apparatus that looks a bit like this. And you would be able to simultaneously, you'd be able to add hydraulic fluid and nitrogen as needed. Electrical power servicing. So this right here is an interesting one because it says electrical power, but you're going to be servicing the oil on the integral drive generator, IDG. So in this case, this task will be draining the oil from the IDG. This is mounted on the engine. So this is our IDG, and you'll check your engine oil. If you're going to drain the oil from the IDG, you would want to make sure that there is no trapped pressure inside this. So you're going to have to bleed off any air pressure from the IDG before you remove this plug. If the engine has been operating prior to you servicing the oil, I guarantee you will have some kind of air pressure. If you remove the plug without removing the pressure from the IDG, the plug will separate from the IDG rather quickly, and all of the oil will blast all over the place, and you'll have a big mess. So you want to depressurize your integral drive generator. So here they say point the overflow drain hose into a container when you connect the hose to the overflow drain half coupling. This will prevent burns from hot oil spray. Hot oil can cause burns to the eye and skin. And the caution is very important. Do not use devices other than the approved overflow drain hose fittings. Don't use a screwdriver. You don't take a screwdriver into the generator drain port and stick it in to try to bleed the pressure off. I have seen people do this, but you can cause damage to the overflow drain half coupling. Then your IDG might lose all of the oil during flight, and then you'll have a generator failure in flight. So you want to use only the approved Airbus, or the manufacturer of the generator is Sunstrand, I believe. Then you'd want to use their approved hose to take the pressure off of the IDG. A lot of the time what you'll have is you'll have the drain hose, and it will go into a bottle that is physically attached to the hose. And as you attach to it, then if you have a lot of pressure, then the containment will be achieved by the bucket that's attached to it, the bottle that's attached to it. You notice it says you need a 2.5 gallon container below the IDG, 10 liter. So then to service the IDG, you're going to need 2.5 gallons of oil, or 10 liters of oil. You always want to wear goggles when you cut lock wire. If you wear just glasses like I do, you can have pieces of the lock wire, or in my case, I had some Skydrol come over the top of my glasses when I was breaking a piece of safety wire. Some Skydrol went up over the top of my glasses and got in my eye, and then I had to have somebody walk me to an eye wash because I couldn't see anything. So their recommendation to wear goggles when you are cutting lock wire. It's a unique one that's in Airbus manuals, but it's good to use whenever you're cutting lock wire on any aircraft type, because you don't want to have fragments of the lock wire get into your eyes. Even if you wear eyeglasses, you're still not fully protected from flying particles and chemicals. If the drained oil has a fuel odor, then you would want to follow this task, servicing the IDG after oil chemical contamination. You should not smell fuel in your IDG case. There's no reason why it should smell of fuel. So if this has happened, then perhaps somebody used a servicing cart that had been incorrectly serviced. And then if the condition of your drained oil is not correct, you'd want to do a sample of the IDG oil for analysis. And we want to fill the IDG oil after we've drained it, and then we would use this task here. So it has a note, 2 notes. They say in case of an oil type or a brand change, they want you to refer to a task 24-21. IDG is part of the electrical system, 24-21. So they want you to check that in case you're changing your oil type. This would be something that would be if you're changing the supplier that you're using. Normally you would not want to use an oil that was not part of your maintenance program. If for some reason you use Mobil 254, and then somebody at your airport, you only have Mobile Jet 2, you would want to call maintenance control and ask them what you're going to have to do, because you don't have enough of the approved oil that you previously had in the IDG. You'd want to make sure that you don't intermix different oil types. You'd have to consult with your engineering department and find out what to do. But this is more important here. In rain, fog, or wet conditions, be careful to prevent water contamination of the IDG oil during the filling procedure. So normally you have a self-contained servicing unit that you're going to fill your IDG. But if you're using a system where you just have a metal can and you puncture the metal can with a tool that you then use to pump the oil into the IDG, that's quite possible with that to get water into your oil during your filling procedure. So the equipment that we had when I worked at the airlines was not self-contained, so then we could get dirt, dust, or water into the system if we were not careful. You connect a pressure fill hose to the IDG, and then you have to have a drain hose attached as well. As you pump in with the pressure hose, the drain hose allows air to vent out of the IDG. And you stop filling when you have drained a minimum of, for whatever reason, they say 0.95 liters or 0.2510 US gallons minimum out of the IDG. See, what you'll do is you'll pump the oil into the IDG until you get at least 1 quart, 1 liter, to come out of your drain hose. Why Airbus uses liters, I don't know, because you're going to find your oil is supplied in cans that are in quarts, not in liters. Why don't you guys take a break? Take a break for 20 minutes, and I will see you soon. Take a break. If you need, you can wander around, get something to eat, and I will see you in 20 minutes.